guys, how are you doing? Nice to meet you. Today we start out the very last topic, and it is about integration of the functions. Integrations of the functions. Of the functions. Here I can allocate two different topics. They are indefinite integral, indefinite integral, and Riemann integral. Indefinite integral. It is about definition of the so-called antiderivative of the function. Riemann integral, it is about a definition of, it's better to say the area between which the area bound to the curve of the function axis is and two given boundaries. I denote them like A and B. And here I give you some scheme. Here you have AB boundaries, axis x, y, and here you have the f of x function. And this shaded area you can calculate if you calculate the Riemann integral, which is denoted like this formula: f of x dx. And here I put this is special sign of integration, a and b boundaries. Classification. So it is the Riemann integral. I put here this red cloud, and here we have indefinite integral. Indefinite integration we denote usually like using the capital letter f of x, which is denote like using the same sign of integration, f of x dx. By the way, I think that this sign goes from the letter S, because it is it derives from summation, infinity summation, and I think that's why they use this letter S like summation to denote the integration sign. And this f of x is said to be antiderivative if its derivative with respect to x gives exactly f of x. I give you here an example with no calculation. For example, if f of x equal, for example, x, an example, antiderivative of f of x equal x squared over 2 plus any constant. And it's fair enough to say that derivative of this function, if I calculate f of x derivative, gives me 2e times 6 over 2 constant derivative, and it gives me 0. Here I can cancel 2, and it's exactly x. So I was kind of correct, because f of x here is antiderivative of this f of x function. Okay, some basic ideas. How can we calculate these so here we have some basic idea how we can calculate this indefinite integral or antiderivative of the function. So if I'm talking about indefinite integral, it is about mu mean and these refer to antiderivative calculation. And we unfortunately there is no very standardized and static way to calculate indefinite integral, and it depends on your creativity. But we can use some rules which can facilitate our efforts to gain the indefinite integral, and they are first one. If there is summation of two functions, I denote them like u of x plus v of x dx. This one thing gives us, we can calculate antiderivatives of these two functions separately. And the same words I can say about subtraction. The second one. If we have some constant times u of x dx, we can take beyond the integration this constant and calculate antiderivative of the u of x function if a is a constant. You can do this thing if a is a function of x. It depends on x. What else we can do? Okay, we can use so-called a trick with variable substitution. For example, what do I mean? For example, you have derivative you have integration. You have to integrate u of x dx, and for example, you can express x through function of t, add new variable, and it gives us u of t times here we have derivative of x dt. Sometimes this thing facilitates our calculation of the integrals, and the last one thing here so-called partial integration by parts. And the last one, integration by parts. For example, you have integration u dv here, and you can make it like u times v minus v du. You can use this formula by parts. So using these four rules, so for properties or for traits, sometimes we're unable to calculate integral or antiderivative of the given function. Sometimes it's impossible. So don't be very concerned about disability of integration of some functions. Maybe it's impossible at all.